Okay. Let me see. We'll go full screen. Let me make sure this will change screens. There we go. Okay.
It's working? Okay.
Yeah, I think we're good. All right. Sip of water. All right. Good afternoon, or dober dan, for those of you in Slovenia. My name is Kevin Myers. I am a network architect with IP Architects. We do work all over the world, based out of the United States. And just to tell you a little bit about myself, I think I've met and talked with a lot of you here at the MUM, but I live in Jackson, Mississippi, in the United States, and for a lot of people in Europe that don't know where that is, that's where Elvis was born. So you know Elvis, you know where Mississippi is. And I've spent about 18 years in IT, network architecture, and engineering, doing various things in the server world, data center, ISP, things like that. We have several different design focuses that we spend a lot of time on. One of them is MikroTik integration with large multi-vendor networks. So we do deal with a lot of large networks, both in the service provider world as well as the enterprise world. We do a lot of design, implementation, and operation of BGP, MPLS, OSPF, networks for wireline and WISP service providers, as well as we do the same kind of a thing for data centers, both enterprise and cloud. We work on those as well. Certifications, I think I've done most of what MikroTik has to date. MikroTik certified trainer last year in Miami and the MTCINE, as well as some of the others, and I've also done some Cisco certifications as well as Microsoft. So before I get into the presentation, I want to talk to you just a little bit about IP Architects, the firm. I think I've talked to a lot of you guys have come by our exhibition booth where we have the giant Tic Tacs that you can't miss. And we are based out of the United States in 2 locations, in Denver and Mississippi. And we've also started support in a location in Canada, up in Montreal. And we are the #1 ranked MikroTik consulting firm in North America. We are the most successful MikroTik global integrator. We bill thousands and thousands of hours in MikroTik engineering across 6 continents yearly. We were the first consulting firm to offer 24/7 MikroTik technical assistance with enterprise-level SLAs. Our SLA for our 24-hour support is the same as what you would see with Cisco. We have SLAs as low as 4 hours for 24/7 MikroTik support. And we also operate at a large scale, supporting some networks that get into tens of thousands of routers, switches, firewalls, and other network devices. So we worked in medium scale, and we also work at very large scale. The services that we offer are global professional services all around the world, here in Europe, South America, Africa, Asia. We do consulting, engineering for all kinds of things. We've done VPN solutions that were beyond 100,000 users. We've done large-scale PPPoE deployments, large-scale BGP deployments, things of that nature. We also have fully managed network services, so if you want full management of your network or just a part of your network, we do that as well. And we also have 24/7 support contracts per device. So if there's a device that you want supported and you want to be able to call and get assistance on, but you want to manage yourself, we have a product for that as well. And we're multilingual. We support in English, French, Polish, and Spanish. We have engineers that speak all of those languages. So because we're so global, we try to use as many languages as we can in our support. So this slide, for those of you that have become MikroTik trainers, you're going to recognize this slide because Yanis Migas loves an objective slide, and if he sees a presentation without objectives, then he's going to say something to you. So I put this in here especially for him to put a smile on Yanis's face. So the first thing we want to look at is identifying the use case for virtualizing public BGP routers and providing full table BGP peerings in transit. So a lot of you that have worked with MikroTik over the years, have known that MikroTik is great with a lot of things BGP, but when it comes to CPU utilization, you get stuck on one core, and V7 is supposed to fix that. But if you've come up against that solution, and you want to sell transit to your customers and you want to peer with your customers, it can be a big challenge, because if you have 50 customers that you want to sell peering to, scaling those resources is a huge challenge. And so we've kind of come up with a solution that we designed and pioneered using the cloud-hosted router that we think will help to solve some of those challenges. So we're going to discuss practical designs with a smaller network with just a few of these, and then we're going to look at some designs at how we can scale this out to multiple PE routers. We're also going to do a little bit of an overview of using the cloud-hosted router in VMware ESXi, which is what we tend to use in our lab. We've got 4 ESXi host servers that we do a lot of our development work with, and look at it getting 10 gig into it. So one of the things I wanted to start with as I was putting this presentation together is kind of go over some virtualization things. I know a lot of you probably are very familiar with virtualization. Some networkers don't tend to get into the guts of virtualization as much, so I'm going to go over just a few key terms here. We're going to talk about something called a hypervisor, which is basically a virtual machine host. It's a piece of software that allows you to run other virtual machines on top of it. And it's basically a server, and you have the hypervisor software on top of it. In this case, our hypervisor is ESXi or VMware that we use to run the virtual machines. Para-virtualized NIC. Para-virtualized drivers are ones where the virtualization does not have to emulate something else. So if you guys have ever messed with VirtualBox, you've ever messed with VMware, you've seen the E1000 1 gig driver that is a kind of a virtualized NIC, but it's not the exact NIC that may be on the hardware. In this case, a para-virtualized driver can actually leverage the driver of the actual NIC that you have in the server. So if you have a 10 gig Intel NIC on the server, it can actually support that natively, and you get better performance out of it. vSwitch. One of the other things that you have to deal with when you're dealing with virtual networking especially is the concept of a vSwitch. So we have physical switches that we put VLAN tags and we connect devices with. But you also have a virtual switch that can live inside of a hypervisor. It can actually live inside multiple hypervisors. In some data centers, you may have a vSwitch that spans 20 rows because they have distributed solutions like that. So what is the problem that we're trying to solve? First and foremost, it's resource utilization. If you've done a lot of peering in BGP with MikroTik, you know one of the challenges that you run into is resource utilization. We've only got 1 core available for BGP, which can become a bottleneck even on something like a CCR 1036 or a 1072. And so when you have many peerings and routes, the CHR can run on a more powerful CPU and can scale a little bit more because you can spin up multiple instances of it. So scaling transit. If you want to be able to use virtual routers to provide transit and peering, you as an ISP can do this much more easily. Not only because it gives you the ability to offload the resources, but if you're distributed geographically and you need to enable a service for a new customer, you're not running down to the CO or you're not running down to the data center to put one of these in. You're spinning it up virtually, so it's saving you time and money in trips to the data center. And then cost, obviously, because if you're going to use a box to peer all your customers into, all your downstream customers, and you're only using a certain amount of resources, then the cloud-hosted router, which I think is $250 they published for the unlimited license, you're only in for $250 to serve a peering customer. So economically, it's a great win. And then redundancy. The other nice thing is if you are peering to your downstream transit customers that you're selling to, you've got redundancy because you may have multiple hypervisors underneath this router, and you may lose one of those servers. And so you can have a single peering to your customer, lose a physical hypervisor, and still keep that peering active to your downstream customer. So there's a redundancy aspect to this as well. So let's look at a simple topology here. First thing we're going to do is look at these. We've got a couple BGP peerings that we lit up in our test lab. These are actually, we're emulating real peering points in Amsterdam. There's an IX in Amsterdam that RIPE takes routes from. And there's also an internet exchange in North America in New York City that they take routes from every 12 hours. And so we actually used a virtual machine that I'll tell you about a little bit later. I think actually some of you have come up to me and we've talked about the virtual machine that we put out that does the 500,000 BGP routes. And so that's what we use to help validate this solution. And so if you look at these two routers here, we've got CCR 1036, BGP1, and BGP2 that we actually put real 1036s in our lab. These weren't virtual machines. These were real gear in our lab. We took a CCR 1072 that we have in our lab and made it our routing core. And then we took our Hewlett-Packard server, we put VMware software on it, and then used that to spin up our cloud-hosted router, which is over here to the left. And then to simulate the aggregation or distribution of your ISP network, whether you're a WISP, and that's an RF shot. If you're a fiber provider, that may be a fiber link to your distribution node. We put a CCR 1009 down here at the bottom to emulate that. And then we decided to make the customer router an RB3011 just because it comes with a gig of RAM and we could put a full table into it. So that's kind of our mock-up that we're working with here. So a lot of people have asked when we talked about this topic, well, there's already an x86 router. Excuse me. What do I get out of the CHR? Why should I even bother with the CHR? And the answer is the para-virtualized NIC. If you're using the x86 box, you can only get up to a gig of transit. If you're using the cloud-hosted router with the VMXNet 3 NIC, which we're going to talk about in a little bit, you can get 10 gig of transit of traffic through that router. If you have a 40 gig NIC in that server and you have enough resources, you may even be able to get 40 gig of transit through that cloud-hosted router. So the ability to scale and get into big numbers with the cloud-hosted router is much more available than the x86 was. You've also got some other things here. You've got 64-bit support that's built in. One of the things Giannis has been talking about with FastPath is going to be built into the cloud-hosted router, and the support's there that you're not going to have in the x86. So you'll have FastPath support. And you're also going to have a lot more wide-ranging driver support. You're going to have the ability to support a lot more things than you would in the x86. And then if you talk to MikroTik, they're going to tell you there's future enhancements to the cloud-hosted router that are coming that they've been working on. So let's look a little bit at just what we did to put this in here real quick. For those of you that have ever used vSphere with VMware, you'll find this very familiar. We, right up here in our list of all our VMs we have in our lab, which is pretty long. I think we've got about 100 and something VMs running in our lab. We put the cloud-hosted router in our lab and set it up as a BGP PE. And I guess now's a good time to tell you, in using the terms PE and CE, I'm not using them. Some of you that are familiar with MPLS, where you have an MPLS L3 VPN, PE and CE. I'm not really using those terms in that sense, more in the sense that you have a provider edge router that demarcates the provider edge and a customer edge router that demarcates the customer edge. So here's our cloud-hosted router that we built, and you can see the console here. And then the VMXNet 3 NIC that we talked about before, if you go into the network adapter that you want to build onto this, you have to select the VMXNet 3 NIC, which is a special type of NIC that allows you to use as much physical traffic as is available on the server. So here's the logical topology for the simple topology that we're going to look at. You notice we still have our two BGP peers up there that we're putting routes into. We've got our two BGP edge routers. And then we've got our core router. But in the logical topology, we've jumped straight down into the PE router. And then we used VPLS to connect this client router into the PE router. And there's a few reasons for that. We're going to talk about why we used VPLS to connect it in, but it ends up being much more efficient for your core. Most of your large providers, at least in the United States, Verizon, AT&T, Level 3, this is the way they actually connect their downstream customers. They leverage their MPLS core, and then they use virtualization overlays in their network to bring their customers all the way back to a POP, or a point that you can serve your BGP routes. So, using VPLS to deliver a direct level 2 handoff for transit. Why would you not advertise the full BGP table throughout your network, or why wouldn't you use an MPLS L3 VPN? Well, there's a few reasons. The first is resource utilization. The router memory that you have available, a lot of people that use MikroTik have different memory available in their routers, different eras of routers in their network, and you may not have enough memory to do that all the way throughout your network and advertise a full table all the way to the edge to your customer. And it also burns up an enormous amount of resources for very little benefit. Most networks that have a small number of BGP peerings, if you've got less than, I'd say 4 BGP upstream full table peerings, most of the traffic engineering that you need can be done through some other means than dumping full tables all the way down into the network core. So your convergence is going to be much slower. That's another challenge. Isolation and security. If you're 15 or 20 hops out for a customer that you need to connect, then if you are going to use a VPLS overlay, you suddenly have obscured those 15 hops of your network from them, and all they see is a public /30 to peer into you, and they don't see the underlying MPLS network. And so from a security perspective, anywhere that you can hide the network a little bit from the end user helps, because it limits what we call the threat vector, the ways that people can see and attack the network. And it also allows for more granular segregation of your customers, because you can put VLAN tags out on this. You can put thousands and tens of thousands of customers out with, using VLAN tags over VPLS, should you choose to do so. And then if you're not an MPLS shop, EOIP, which is a great protocol that MikroTik has that's proprietary, will do that L2 transit, and you could use EOIP to do this too if you're not at the point where you can enable MPLS in your network. Uh-oh. Hold on, let me catch up here. Okay, so we're going to look at our upstream provider number 1, just take a brief look. We've got, I didn't take the time to let all 500 and I think it was 55,000 routes go into this out of the VMs that I was feeding into these routers. So I think we got 300,000 on the Amsterdam peer. And you can see that right there that's highlighted that we're taking in. And this is actually not a live peering. This is all within our lab. We put 300,000 routes into these routers just using our lab equipment. Let's see if this works. And then you can see the North American peering into New York. We only let it get about 67,000 routes. We had 550,000 available, but the machine we use takes a little bit of time to spool up the BGP connections, the routes, so we let it stop at 67 for the purposes of this test. And so here we're going to move into our cloud-hosted router. This is our actual BGP CE that we've spun up in VMware. It has a peering out to BGP 1, and it's got a peering out to BGP 2, and we're taking in routes from each of them. And at that point, when we snapshotted it, we were up to 338,000 on one and 96,000 routes on the other. So just over 400,000 routes goes into this PE router that you're then going to use to serve transit to your customer. And then ultimately, here's your customer router. This is the CE router for the customer. They've peered with the PE over the virtualized network, over the VPLS overlay, and they're pulling in 400,000 routes, and we've announced the routes in our lab network, so whatever routes they want to announce, they'll announce. But if you look in the network core that's supporting MPLS, it only took 14 routes to get that job done. So because we used the overlay, we used 14 routes to connect a customer downstream and serve him 400,000 routes. So how do you scale with the BGP PE using the cloud-hosted router? It's an interesting question because the cloud-hosted router is a very new product and it's still developing, so there's a lot of exciting things that are going to come. MikroTik's been working very hard on it. We've been talking to MikroTik about their development, and the reason they're doing this in the data center space, especially any of you are cloud operators, like cloud data center operators, virtualized routers are a big deal right now. In the United States, the customers we work with in Europe, virtualizing network devices is very hot right now, and there's a lot of people doing it, so MikroTik has recognized that and is trying to get in on that trend to have a product just like their other products that competes at a much lower price point to be able to put into cloud data centers. So we could add more peerings if we want to scale beyond the one customer that we peered with to our BGP PE, and that can go for a while. We could maybe do 5 or 10 peerings depending on what kind of a processor you have on your server, how much horsepower you put into it. And then we could add more cloud-hosted router BGP PE routers. So we could keep adding more PE routers, and maybe each of those PE routers will serve 2 or 3 customers, and then they will peer back to the BGP routers. So that also lightens the load on your BGP edge routers because all of your transit customers are not peering back into your main BGP routers. So you don't want to add too many full table routes, peerings to the edge, because this can put a dent in your big routers, your BGP routers. So the answer to that, if you want to scale beyond that, beyond getting the 5 or 10 or maybe 20, is to look at route reflection. And you spin up another virtual machine, another cloud-hosted router. And you can use route reflectors to feed multiple PE routers. So here is a little bit larger scale topology that you could use to build and make it very large if you wanted to. That shows we have a route reflector up here. So now instead of the PE router, that's a route reflector up in the top left there. And then we have 3 PE routers, and we now have 6 downstream customers that we're peering and selling transit to. So if you look at this in the logical model, you'll see I've got all these customers, 2 per provider edge router, and then they all come up through the route reflector. Now, something that's really interesting to note about the route reflector is, and we run across this in design a lot of people feel that the route reflector needs to be in path of the traffic, that it needs to be one of your core routers. It actually does not. You can actually deploy a route reflector at a POP or somewhere that's not in the data path, and because iBGP doesn't change the next hop by default, you can actually have a route reflector that no traffic goes through other than BGP peerings, and it will serve the routes out to all of your routers, almost like a database of routes, truly a route server. So you can feed all of your provider edge routers in that way with a route reflector, and you can even add more route reflectors to help you scale. So if you have 20 customers or 50 customers that you need to sell transit to, you can use this virtualization technique to help you scale way beyond what you have in your hardware routers. So adding the route reflectors for scalability, you can reduce the number of peerings on the BGP border routers and get your resource utilization down. So we have a 6-to-1 ratio here, and what that essentially means is we only have 1 peering coming from the BGP border routers back to a route reflector. So that border router that you connect to any of your upstreams only has to do 1 peering and dump 1 copy of the full table back to a route reflector. It is then the route reflector's job to distribute that full table to any of the PE routers that it talks to, and then it further distributes that. But if you have a flap, it's easier to spread those resources across all of these than to have 50 peerings on your BGP routers and then watch them tank as you try to serve 50 copies of the global table to your downstream customers. And as we talked about, route reflectors don't change the next hop by default. They can if you want them to, if you have a need to, but they don't by default. So if you use OSPF and BGP, and in your iBGP autonomous system you peer with loopbacks, then this is a very achievable thing, because OSPF carries the next hop for BGP. So if any of you have read stubarea51.net, we've done a lot of blog posts and a lot of MikroTik tests and things like that. One of the things we tested on the CCR 1072 was the ability to put route reflection full tables into other routers. So we actually dumped 1 million routes into the CCR 1072 from 2 different providers, and then route reflected those down to 2 other routers, and then we timed it to see under perfect conditions how long would it take. And on a CCR, we were able to get that done in just under 2 minutes. So if you're using this on a CHR, which is going to have a more powerful processor, the Tolera is a great processor, but per core, the Intel you still get more out of. So if you put the CHR on an Intel architecture, you'll likely see it happen even faster. So one of the interesting things to look at in the comparison here is for any of you that have worked with Cisco and any of Cisco's virtualization products, they have what is a competing product to the cloud-hosted router. It's called the ASR 1000V. It's a Cisco router in a VM that uses iOS. If any of you have ever used Cisco routers, it looks, smells, and feels just like a Cisco router, but it's in a VM. And much like MikroTik, they license it for how much throughput you want to put into it. But unlike MikroTik, they license things like IPsec, and if you want to use multiple cores, or if you want to have multiple VPN connections into this box. And so the licensing costs are extremely expensive for what you're doing. And the other interesting thing to note is the Cisco VM is only capable of 5 gig of throughput with MPLS, whereas the MikroTik VM is capable of beyond 10 gig of throughput with MPLS. So here's a case where you have a MikroTik product that really seems to be way ahead of the Cisco product and the capabilities that it can deliver. So I think you're going to see a lot of neat things out of the cloud-hosted router, because if you go look up the prices online for the ASR 1000V and add all the licenses up, to get upwards of 10 gigs, which you can't even get in MPLS, you can get 10 gig of normal IP transit, it's going to cost you upwards of $30,000 US dollars to get that Cisco VM. In the MikroTik cloud-hosted router, unlimited throughput is $250. So if you're a cloud operator and you need to put this either as an ISP, if you're a cloud data center, this is a much more economical way to do this, and you've got more performance available. So it's a really interesting proposition for deploying this virtual service, this virtual router. So we've talked a little bit about stubarea51.net. Some of you have talked with about Stubarea 51. We do a lot of different things with MikroTik and network engineering in general. Stubarea51.net is the official blog of IP Architects. So we write articles, we do testing, we do things in our lab, and we publish it out to stubarea51.net. And one of the things we published most recently was there was another person on another blog who figured out how to get a full BGP table out of RIPE into a Linux server. And so we thought, well, that's a really good idea. Why don't we take that work, which we did credit and said he really kind of had the hard part of it, and let's put that into a VM that's a VM template that you can distribute and deploy. And if you need 1 million routes to test in your lab network, well, go spin up a couple of VMs and you can dump 1 million routes, BGP routes. And unlike, I've talked to a lot of people, they're like, well, I could spin up a script to spin up 500,000 routes. And you certainly can, but these are live routing tables pulled from internet exchanges. So they carry with them all the AS paths that existed at the time, all the communities that existed at the time, all the prepends that existed at the time. So if you want to make your network look like a real production ISP network with peerings, you can spin it up and start to do traffic engineering and different things like that. So you can find that as well as a bunch of other articles on MikroTik if you go to www.stubarea51.net. And of course, if you haven't been by the booth, come by, get your Tic Tacs at the 8-foot Tic Tac container over there. I know we gave away about 700 Tic Tacs, which took a little bit. We had to ship 30 pounds of Tic Tacs from the US to get them over here. So please come by and talk to us. And some of you have asked us, why Tic Tacs? And what does Tic Tac have to do with MikroTik? When we started our 24-hour operations center 3 years ago, Cisco has the Cisco Technical Assistance Center. If you work with Cisco and you have a problem, you call in and you call the TAC. And Riverbed is the same way, and so is HP. They all have a TAC. Well, we thought, well, MikroTik needs a TAC, and so we're going to start this. So as we started developing this and getting our marketing material together, we noticed that when you say MikroTik TAC, it sounds very close to Tic Tac. So we showed up in St. Louis 3 years ago with a full life-size Tic Tac container made out of plexiglass and foam Tic Tacs. And so now we brought the lighter weight version for Europe over here. And so for those of you who've been wondering why and what that is, that's the rest of the story. And now I'd like to open it up for any questions anybody may have. All right, questions? Yes, sir. In the blue shirt. Yeah, yes. Could you speak a little bit louder? Oh, for the CHR. So I believe the posted hardware requirements, they've changed a little bit over the development, but the current hardware requirements are you have to have at least 128 meg of RAM, and you have to have at least 128 meg of disk space. There was a period of time where you could actually load the CHR with only 64 meg of RAM, which we used a lot because if you wanted to build like a lab network of multiple devices, we'd use very low amounts of RAM so we could spin lots of them up. But in the latest version I've tested, it's gone back to the official 128 megabytes of RAM minimum and 128 megs of disk space. So in today's world, most of our laptops can spin up, probably 10 or 20 of those, VMs without very little effort. All right. Any other questions? Yes, sir. Let me come to you because it's a little hard to hear. There we go.
So my question would be, if you would like to run, let's say, 2 full BGP tables and then 10 gigs of internet traffic from your provider, which would be acceptable minimal hardware requirements for this kind of setup?
Okay, that's a great question. So to give you an example of how little you can run it on, when we built our lab, we didn't go buy the latest and greatest servers because we didn't need them. We weren't running a production network. So we got HP servers that I think were about 4 or 5 years old when we did our 80 gig of throughput test. They had Intel Xeon 5570 quad-core processors, and I think we only had 32 gig of RAM on the ESXi host. So, to get to those speeds, you would probably want to put at least maybe 4 cores behind it to get up to 10 gig. And MikroTik is still working on the throughput as they're developing the VM. So I think that's something that, they've tested it, and we'll continue to test it to see how far we can take it. But I know with the Intel 5570 chip, we can comfortably get to 10 gig in a VM.
Okay, thank you.
Sure. All right, any other questions? Okay, great. Thank you very much for your time.
Thank you very much, Kevin. The next presentation will be by Warner Maya. And I want to remind you about the beer. Those who do not need to drive, 6 o'clock. See you there in the hall.
Yeah.
And microphone.
Good one. Thank you.
This one. Which one? You can use this or this?
I think this.
Okay.
And when I do.
As I switch it off, do you want to switch it on?
Yes. I will use this.
Okay.
But when I go to the.
Okay, then we'll need. You can talk for 1 hour.
Yeah.
As you promised Yanis to talk, not to talk too much, but
Yeah.
if you like, you can.
No, I prepared for 45 minutes.
Okay.
Because the competition with the beer.
Te 5 minut, to minus 6.